Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper trending on X, published on July 10, 2025, about 5 days ago. This paper introduces a new memory system that achieved a massive 410% improvement in accuracy on a multimodal benchmark. The paper is titled MIRIX Multi-Agent Memory System for LLM-Based Agents. That's 2507.07957v1. And its unique architecture is what makes these powerful results possible. It proposes a novel system using 6 specialized memory types, each managed by its own dedicated software agent. Alright, so this first figure breaks down that unique architecture. We can see the 6 distinct memory components. You have core memory for user preferences, episodic for past events, and semantic for concepts. Then there's procedural for step-by-step guides, resource memory for files, and a secure knowledge vault for sensitive data. This structure is a big departure from typical retrieval augmented generation systems, which usually just pull from a single, flat text source. This specialized, multi-part memory is what allows the agent to be so much more effective and personalized. Building on that architecture, this next figure shows the MIRIX system in action as a personal assistant. We see a chat window where a user asks what project they are working on. The agent correctly identifies the AI system project, its focus, and even its file path. It then answers a follow-up question about a document title. This demonstrates how those different memory types work together for detailed recall. This ability to connect different pieces of information, what researchers call multi-hop reasoning, is a key strength highlighted by this example. So how does the system actually handle those user questions? Well, this diagram lays out the workflow. When a user asks something, the chat agent first performs what the authors call active retrieval, which is an automatic check of all the memory types for relevant context without being told to search. Then, it conducts a more specific, targeted search. The results from all the different memory components are consolidated, and a final response is synthesized. This two-step process, that broad automatic check followed by a focused query, is what enables the sophisticated reasoning we saw earlier. Moving to the results, this table quantifies that performance on the Locomo long-form conversation benchmark. You can see MIRIX using the GPT 4.1 mini model compared to several other methods. The most striking result is in the multi-hop column, which measures the ability to connect multiple separate pieces of information to form an answer. MIRIX scores nearly 84%, a huge leap over its competitors. Its overall score of 85.38% is state-of-the-art, and it gets incredibly close to the full context score, which represents the theoretical best performance. So, to wrap up, the key takeaway here is how MIRIX moves beyond simple, flat memory systems. By creating this structured, multi-agent architecture, with its 6 specialized memory types, it achieves a huge boost in complex reasoning and personalization. We saw this with the massive 410% accuracy jump on a multimodal benchmark, and that dramatic improvement in multi-hop reasoning. It's a powerful new standard for memory in LLM agents. That's all for today's AI Research Roundup. Thanks for tuning in. I'm Alex.